Okay, 7.3. So this is where we get to factoring trinomials, which means polynomials that have three terms would be a trinomial. And what this is going to do, this is basically a reverse FOIL. If we think about back in, I think it was chapter 4, grab a pen, there we go, where we had something like x plus 3, x plus 4. And remember, we would do FOIL, so we'd go x squared. On the outside, we get 4x. On the inside, we get 3x. On the end, we get 12. And we collect our like terms here, and so we get x squared plus 7x plus 12. What we're doing in this chapter, this section in particular, is we're trying to get from here to there. So we're trying to go backwards from what we saw as a FOIL. And so if you notice, the numbers on the end, they multiply to be the number on the end, and the numbers on the end add to be the number in the middle. So that's how we're going to know how this is going to factor. We're going to look at this 12 and say, what two numbers multiply to be 12 and add to be 7? So if we think about what multiplies to be 12, we could have 1 times 12, we could have 2 times 6, and we could have 3 times 4. And 3 times 4 adds to be 7, and so that's how that's going to factor. So that's basically this whole section. This particular version of factoring is such a workhorse. If you have to take either Math 116 or 141, you will use this a ton, so definitely want to learn these techniques. And this is going to be, particularly this is going to be for trinomials, so 3 terms. And where a equals 1, what that means is where this number in front of the squared term, these are all going to be 1s. We're going to see some greatest common factors later, but when we factor that out, it will reduce to something like this. So that's where this particular technique works. And we're going to see 2 more kinds of trinomials in the next 2 sections, so we'll cover that when we get there. Looking at this first one, we got what would multiply to be 40 and then add to be 13. So we can set up our parentheses. We know it's going to go y times y, and because it's multiplying to positive 40 and adding to a positive, it has to be 2 positives, because 2 positives multiply to a positive and would add to a positive. So we know these are both going to be pluses. Even though that one's not very good. So then 2 numbers that multiply to be 40 and add to be 13, hopefully you can spot those as 5 and 8. It doesn't matter, I could have put 8 and 5, same exact answer. But that's basically the technique. With the 40, it could also be 1 and 40, 2 and 20, 4 and 10, and 5 and 8, right? There are actually 4 choices. And so sometimes you're going to have to work a little harder to figure out what those 2 numbers are. But if you break down 40, it's always going to be on the list of multiplies to 40. So then these next 3 examples are kind of showing the different iterations that can happen. So if you look at them, there's a positive on the end, this one's positive, this one's negative, and then there's a negative on the end, and this one's negative, this one's positive. So either both the positives on multiplies to a positive or multiplies to a negative. I'm actually going to do 20 first, and then I'll go back and do 19 and 21 together, because they go together a little better. So we need 2 numbers that multiply to be a positive 18, but add to be a negative 18. And so that's going to be a negative 8 and a negative 10. And again, it could be 1 and 80, 2 and 40, 4 and 20. There's other choices in there, 5 and 16. But we're looking for the 2 that add to be negative 18. So here when they multiply to be a positive and add to be a positive, I knew they're both pluses. For this one, since they multiply to a positive, add to a negative, they both have to be negatives. So negative 8 and negative 10. So that's the version where the end number is a positive. And for all these cases I'm showing, it still multiplies to the end, adds to the middle. This is just kind of fine-tuning how to think about it. For this next example, it multiplies to a negative. So if it multiplies to a negative, that means it's going to have to be a positive and a negative that are doing that. Just clean up this stuff. So if I think of negative 40, and the negative ones are a little bit harder, Let's figure out all the things to multiply to be 40, and then we'll work out the signs. So 1 and 40, 2 and 20, 3 doesn't go in, 4 and 10, and then 5 and 8. And then 6 and 7 don't go in, and I'm back to 8, so that means I have them all. So what I need is two numbers that multiply to be negative 40, so one's positive, one's negative, and adds to be negative 6. So what that tells me is when this middle number is negative, that means the larger of these two numbers is going to have to carry the negative sign, so that when I add them together, the middle stays negative. You can see on this next one it multiplies to a negative but adds to a positive, so that would mean the larger of the two numbers would carry the positive sign, because that's what's going to dominate when we add them together. With the ones that multiply to a positive, it's easier to see because 5 and 8 makes 13, 8 and 10 makes negative 8, 18, and then they're negatives to make it negative. With the negative one, it's better to think of it as the space between the numbers rather than what they add to, because the signs make it confusing. So if we look for the one that's 6 apart, 4 and 10, and then we go, it's going to add to a negative, and so the larger of those numbers is going to carry the sign, the negative sign. 4 plus negative 10, or 4 minus 10, there's our negative 6. So with the positive, you can just think of it as a straight up addition. With the negative, easier to think of it as the space between the numbers, and then get the sign right by looking at that middle term. So this one's going to go y minus 10 and y plus 4. If we FOIL all that out, do it, add to negative 6 in the middle, and multiply to negative 40 on the end. Negative 45 there, so negative 45 is our number, and 45, 1 and 45, 3 and 15, and then the more obvious 5 and 9 would be our choices. We want the one that's 4 apart, and so that's the 5 and the 9, and the 4 is positive, so the 9 is going to be the positive. The big number carries the sign there, so negative on the 5. So this will be x minus 5 and x plus 9. And you can always check any factoring problem by multiplying. So if I FOIL that back out, it should come to what we started with. These ones are going to be basically the exact same thing, but they have an extra squared term going. So what that means when we set this up, we set up our x's, because it's going to go x times x to get x squared. And then we also set up our y's on the other end, because at the end we're going to have to go y times y to get y squared. And now it's the same thing. We're just asking what multiplies to be positive 10 and adds to be negative 11. So those have to be two negative numbers to multiply to be a 10 and positive 10 and add to be a negative. And so it'd be negative, I'll write the 1 there for emphasis, but we don't need the 1, but negative 1 times negative 10 would multiply to negative or positive 10 and add to be negative 11. Same thing here. Again, don't let that extra y on there throw you. Just write in your x's leading, y's trailing. So we needed to multiply to be negative 14 and add to be 5. So 14 could be a 1 and a 14 and a 2 and a 7. So it must be the 2 and the 7. The 5 is positive, so that means the big number carries the sign, so that would be the positive, and a negative 2. We just fill those in, negative 2, and plus 7. Again, FOIL it out if you're like, did that really work? Yep, if you FOIL it out, you'll come out to exactly that. Oh, I guess I didn't show the middle term. Let me do that real quick. X times x is x squared, and then x times 7y, so that's how we're getting that middle term back, is 7xy. And then you can see right there we get a minus 2xy. And so that's how we get the xy that we had there. Now these last examples, they don't lead with a 1. And what I said at the beginning of the video was that this technique only works when we have a 1w squared or a 1x squared, what have you. If we have something other than that, and what we need to do is either look for a greatest common factor, which these are all going to be greatest common factor problems because we're in the section where we're working on this technique, or it's going to be one of the upcoming factoring problems that we'll see in the next two sections. The next two sections, especially one of them, is fairly terrible, So if there's a greatest common factor, you really want to get that out of your way. It's almost like if you miss the common factor, you will get the problem wrong. Like it's so hard to then kind of recover if you don't catch that first step. It's possible, um, but much more difficult. So for all factory problems, especially if it looks kind of terrible, look for GCF. So for this one, there's no W in this term, so I know it's only going to be numerical. 4 is my smallest and easiest number, so I know it goes into 12, and it looks like it's going to go into that 28 of the 280. So we'll take a 4 out front, and now that gets us W squared, and that's kind of what we're working on here, is right, the kind where there isn't a number in front. 4 goes into 12 3 times, so that'll be a 3W. And 4 goes into that, it would be minus 7, and then with a 0. Cool, so now this looks like the ones we just did, and we can ask ourselves what multiplies to negative 70 and adds to be positive 3. So when we do that, we just write the 4 out, and we'll go W, leave us some room, another W, leave us some room. So two numbers that multiply to be 70 would be 7 and 10 are the ones that jump out at me. Let's just put them right there. And then if they're going to add to be positive 3, then that means the positive, the big number is going to be positive. So plus 10 and minus 7. And then if you FOIL that back, you would WW times W squared, and then plus 10 minus 7. There's your plus 3 in the middle, and there's the minus 70. And that would get you to here, and then you would just distribute, and that gets you back to the start. Same thing here, but it looks like we can take a W and a 7 out of there. So let's see where that gets us. So if we take 7W out, we're going to have a W squared up front. 7 goes into 91 13 times. That's why I don't know it. Checking my notes. And with these numbers where, like, I don't know what goes into 91, you kind of guess it's going to be 7, right? Because that's the small, easy number. So try that one. And then 7 goes into 210, that would be 30. And no W there because this has the W. So again, if it doesn't come out something squared, then the something and then plain number, check your greatest common factor because you probably have an error at that spot. So 7W, we'll set up some W's, leaving some space. So I need two numbers that multiply to be 30 and add to be 13. Sounds like 3 and 10. And we got it. And these last ones are just more of the same. Let's see, so I would, again, I don't know off the top of my head what goes into 192, but I would certainly try 8 since it's the easy number sitting there. And then Z4, Z3, Z2, so I can take out a Z squared. So let's try 8Z squared. And that will leave a Z squared there, and it should count down Z squared, Z, and nothing, right, because we're counting down by ones and our exponents. Let's see, 8 out of 40, so that will leave me a minus 5Z, and then 8 goes into 192, looks like 12. I'm sorry, 24. Oh yes, because it goes in twice, my bad, 24. And then the Z squared came out. So now we just need two numbers that multiply to be negative 24 and add to be negative 5. So jumps out at me is 8 and 3, and those are 5 apart. So it'd be a minus 8 because the big number carries a sign, and a plus 3. This last one looks like we have a common theme of 6's, so let's get that out front. And then everything has an x. So that will leave y squared. 6 into 36 would be 6. Oops, that should be a y, not an x. And 6 goes into 96. That would be 1 and 16. Yep, 16 times. So then we are looking at, oops, and I just noticed I wrote that sign down wrong. So that doesn't factor. There we go. So now we need, bring down our common factor. I'll set up my parentheses with the y's. And then I need two numbers that multiply to be negative 16 and add to be positive 6. And so, again, if we had 1 and 16, 2 and 8, and 4 and 4, we're looking for the space between the numbers, so 2 and 8 are 6 apart, so that's one that we want, and the big number carries a sign, so it'll be a plus on the 8 and a minus on the 2. So minus 2 and plus 8. So that is factoring trinomials where either they lead with a 1 squared term, a coefficient of 1, or we can simplify it to that.